All right, so welcome everybody to the March meetup of DevOps Finland. So for all the new people, if you don't know me, I'm Timo Sturla. I'm one of the organizers in this meetup group. And here is my colleague Niko Kivelä, who is organizing these meetups. So if you have any questions or ideas for these events, please let us know. Primarily, what we are looking at next is the host for the April meetup, because sounds like we have lots of speakers already in the back pocket, but we don't have a place for it. And there have been at least some people who have been contacting me already about this. So please let me know if you are ready to host a meetup for April or May. In June, we might start the summer break. So today, well, things go like before. So we are still the biggest meetup group, biggest professional meetup group in Finland, chasing the meetup, which is a kind of a bit of a challenge because they have let's say 500,000 potential members, and we have maybe 5,000 in the Helsinki area. But yeah, it looks good, and we try to keep the kind of a thing living here also in the future. So so please let us know that what you think about the content we have here, and let's keep this running. I don't have anything further, so I give the word to Siili. Here, yeah, Niko. Yeah, we don't have a live stream today, but there will be a recording of this event. So if you happen to miss today something, so you can check that afterwards. And for the recording, so if you have any questions during the event, so wait for the box. So this will be thrown to you, so you can get your voice to the recording as well.
And if you don't want to have your voice on the recording, then don't accept the box. Hi, my name is Heimo. I'm from Siili Solutions. I'm a consultant, so I'm going to be talking about a subject that I know almost nothing about, so cybersecurity. But trust me, I'm a professional consultant, so I make it sound good, at least I hope. This might be a short presentation depending on how you interact with me. So if it seems that I'm boring, just show with your hands that go on, we already know this, and we can continue back to the food and drinks faster. If you have questions, wait till the end, and you might get the box and ask silly questions from me. The talk is about how I stopped worrying about cybersecurity. And the context for this is a project that we have been doing for some time. And my goal here is actually convince all of you to love your security people more. So the agenda for this talk goes through presenting the context. So why I have been thinking about security lately even more. I will say a few words about threat modeling, and then how security is actually a continuous activity that should happen through processes, how security is a mindset, and then have few ideas how we could possibly cross-pollinate these different communities better. But why I'm interested about security lately? So we have been doing on national level interesting project, and it has raised lots of questions in my mind. I don't know about you, but I've seen more and more presentations and news about the threats, how they have evolved, and what kind of problems people have had in the industry. Just previously, in last few weeks, we heard more about the LastPass breach. Of course, Vastaamo case has been in the news again because they have been having the court cases. The ransomware cases, almost anyone can be a target these days because, well, the world has changed. There are lucrative reasons why people are doing cybercrime, and of course, you can be just like accidental victim. You don't necessarily have to be a big target on your back, known to be interesting target. You might just accidentally become target. And I absolutely love this slogan that Disobey has been using. Everything is broken, nothing is secure. It's kind of like what Werner Vogels has said about IT, that IT breaks all the time. So having this mindset is actually quite liberating, because you have to accept the reality as it is, not trying to say that there are no threats in my world. In this project that we have been doing, I've been highly blessed and grateful that we have had good friends walking the path with us. We have been working with specialists from Silverskin Information Security, and those people have actually blown my mind with the craftsmanship and ability to open my thinking to security topics. I'm not totally newbie with security topics, but they have been guiding me on our thinking and on the path very nicely forward. So this kind of advisory thinking has been truly helpful, getting me and our team past those like naive thinkings about information security to actually focus where it matters. Jani Kirmanen and Timo Hännikainen have been like huge friends in this process. And I'm basically saying that you should have similar kind of friends in your teams, because professionalism matters, and professionals truly differ from like those who are laypersons on these topics. Besides this advisory thing, on the roadmap we naturally have these more traditional information security things like penetration testing and a good validation for things. But those are not interesting because everyone is talking about those. I'm going to talk about everything else than penetration testing and validation. So something that everyone should be bored about is threat modeling, because threat modeling has been a topic that all the cybersecurity presentations had a few years ago already. So we should know about this topic. But how many actually does threat modeling, and does it well? Why threat modeling is important for me is because you can be totally overwhelmed about the possibilities that can go wrong in the world, especially if you are doing important projects or complex projects. The threats don't necessarily start with technology. So how you actually understand what are the threats to your business, you should start the thinking from understanding what are the crown jewels, what are the assets that you need to protect. And from there, actually figure out how those can be compromised. Whether you are actually the target or whether you are just the conduit through which somebody might be accessing somebody else's data and trying to hurt someone else. You might think that, okay, we are not doing anything interesting, but if you are leaking someone's personal information, you might be actually a target because somebody wants to target some person through you. And understanding these things is not trivial. You have to understand what is the impact of the service you are providing, what is the impact of the data you are handling in your systems. And it always starts with the business and understanding the real world around what you are doing. The big thing for me was to switch my head from this creator mode to actually understand how somebody could try to use these systems and capabilities against us. So I'm the first one to say that I needed lots of help in this creative mindset to figure out the real threats. And luckily, there are very good resources available. So you can grab a book, you can participate in workshop or seminars and improve your thinking. But it's different kind of thinking than in your creator mode. You had a question already? Oh, sorry, okay. So few things that I want to point out is, of course, the classics from Adam Shostak. He just released a really nice book with Star Wars theme. So threats, what every engineer should learn from Star Wars. I highly recommend it. Even if you are professional, it's still a fun read and it really tickles your brain. His threat modeling designing for security is an older one, but still valid book. And if you are a geek, then you are going to love Security Engineering, a guide to building dependable distributed systems. There you will learn so many exploits available to physical systems and digital systems. It's a humongous book, thousands of pages, but it's good. And then of course Mitnick's The Art of Intrusion is fun to read because it kind of shows you the mentality that people who evolve into hacking and evolve into intrusion might have. And understanding this kind of behavior from the human set is actually really helpful when you want to have this creative thinking how somebody might attack you. So, security is a process. You need continuous vigilance. In real life, I've seen security more like a step later on in a project, or perhaps a step that happens when something is already wrong. I haven't seen it so much as a continuous practice, though I'm a firm believer that it should be. So in ideal world, everything that is related to quality should be continuous activity, and we would all be taking care of usability, security, and other illeties. But this rarely happens. We don't that often have such a large project or established services that these will be really taken care of. And one thing is also that in many cases, people don't know what good look like. So we don't have necessarily the experiences, what good security operations are, how you are thinking through potential security threats, even in your pull requests, or how do you test whether your code is secure, how it could be exploited, or even whether new vulnerabilities in existing software has been released. So in this sense, good processes can be a key for organization to balance these different needs and remember that, hey, we should be possibly doing these things. This is, of course, very self-evident to all the sysadmin people who have been doing patches and managing servers for all the time. But along the path with other network and software components, we don't necessarily have had these processes running that well. But being aware of what capabilities are needed and what the good practices look like could help in any organization to realize these opportunities to improve the systems. Quite similar how in DevOps practices, seeing the value stream and understanding how the value flows, we can see the improvement opportunities. Now, I'm going to show you something from OWASP, and it's most likely is going to make your eyes bleed. This is just to show that professionals for large organizations are showing all sorts of capabilities that you should have been set up and do properly. This is from OWASP SAM model, which is guiding organizations to set up capabilities so that the operations are well thought and runs securely. Naturally, even in our large project, we are not doing this. We tried to do something simplified. So we identified with our security partner what are the things in the system that we want to focus on. What are the things where we do changes to any of these things we want to go through consciously whether this impacts our security posture in any way. Not going into the details, but we identified that, of course, public interfaces, the core components of the system, and of course the supply chain includes many components, many subsystems that we need to be aware of as potential conduits or targets through which our security could be compromised. And this kind of simplified model is like a heuristic for us that when we add new admin interfaces or operators or components, we need to have activities where we actually vet the person as well as the components and figure out, is this good for the whole system? just to be more aware of our impact when we do changes. After all, security is a mindset. So no tool is going to solve all the problems. This is something that we want to drill down to people and help people to do the right thing, or even just a little bit right there, if not completely right. The really hard thing in security is that you don't need to screw up more than once. A single incident can destroy the whole trust to a service or even destroy the whole company, just like what happened with Vastaamo. And if you are not aware of your security posture, you might create these opportunities for the whole deck of cards to fall down or go down into pieces. And it's always good to remember that we are just failing human beings. So how do we create the system where single failure from a human actor doesn't destroy the whole system? This is or should be quite familiar to anyone who has been fighting with any kind of quality challenges. So organizations might not be ready to invest into these topics properly. So security is just one more addition to the queue waiting for resources, trying to fight for the mind share. And of course, we have to remember that not many of us are grown to as large or as significant that people think that security matters. So this is always like balancing all the efforts. If we have the most secure pipeline and servers, unfortunately, that doesn't really pay the payroll next month. We need to be able to create the service that actually fulfills customers' needs. But then again, if we lose the trust of the customers, then again, they don't give their money to the service anymore. So it's a tricky situation. So big question that we've been thinking is that what are the simple steps that we can take right now? How can we improve the everyday life and just take these small nudges forward in everything that we do? And this is a topic that I would like to have conversations during this evening more. But as an example, I'm just showing a short list that we have been educating to developers. There are many lists similar to it, but this one is mine. So these were the principles that we thought for our team the most important. So some principles are very, very familiar. Principle of least privilege doesn't need any more introductions. So everyone who is using cloud services is familiar with that. Limiting the attack surface and protecting interfaces is quite similar, self-evident, but then again, something that you don't necessarily always remember. Simple example is that in some of the frameworks, when we create new HTTP controllers, they might be automatically accepting multiple different MIME encodings, and through that you might be actually exposing different libraries that could be exploited. So limiting the accepted MIME types limits the attack surface and make sure that you only expose your libraries to some of the possibilities. Input validation, not trusting data coming from outside, including data that comes through integrations. This was something that shook me, but security consultants were like, yeah, it might happen. Somebody who is providing data to you might be compromised, and your system might be attacked through the data. So be aware of that. Explicit error handling is also one thing that I want to be very clear about. So I like functional error handling so that there are no unknown execution paths because of exception throwing and so on. But this is something that is not that familiar with younger programmers. So something I have to be educating people about and speaking a lot about why it's important. So you are doing more readable code, but you are also doing more secure code. Explicit access controls, locking decisions, not only for debugging purposes, but also to enable detection. This is also something that many developers don't necessarily automatically think, meaning that you are actually trying to provide the breadcrumbs for yourself to understand what is happening and what has happened in the system when you need to figure out why it is in the state that it is currently. Thinking this, how functionality could be abused. Once again, feature that security-minded people always try to remind us. Think about how the feature you are doing could be exploited to achieve something that is counterproductive to the success of the service. And then, of course, testing all your assumptions. You can trust the code, but validate that it actually works as intended. Go through different kinds of failure paths, test different timings, and do some lateral thinking, because you might actually learn that the framework you are using has bugs that you are not aware of. But even a simple list like this and providing your definition of done based on this kind of thinking might help you catch some kind of quality errors early on in the process. And of course, educate the whole team of these possibilities. So, what next? I'm proposing that we do more than rename ourselves as DevSecOps consultants. This kind of security mindset is the ability to look things sideways and try to have different perspective to the things that we are building. And I'm first ones to say that when I'm trying to create something, I'm not able to look at the same time how I'm going to break this thing. So quite similar to what testers are seeing. If you are building the system, you might not be the best one to do exploratory testing with it, unless you are really, really good. But I'm the first one to say I'm not that good. So we need to have these different specialities, and we need to include them in the process early on, so they save actually time, money, and effort, and can teach us to think better. And this whole thing is a collaborative effort, the whole idea of quality. So we have multiple different facets and ideas about quality, and security should definitely be one of those. This is highly evident also in regards data privacy. So it's usually the security people who are thinking about data privacy, even though also designers should be more aware of implications of data usage to cause havoc around the world. So big questions. How can we get to know security people more and collaborate better? At the moment, from my perspective, security communities are whole lot own communities. People are drinking beer and complaining why they are not bought more into the projects and how everything is totally fucked up and all the systems are going to fail anytime soon. But luckily I have the tinfoil. So how can we show more love and involve security people better in our processes? And as we are in DevOps environment, how can we create these more secure environments as a whole, where security is woven into our processes and thinking? Not everyone will have a good security team available, but we can have a little bit more security thinking. We can have hack days. We can have workshops from more knowledgeable friends of ours who can teach us how to use tools of the trade and actually try to break the systems. It's actually fun to also do that. There are lots of excellent resources and communities available around the world, and even in Helsinki, Helsec community is great. It's very easy to approach and lots of great people there. They are also the most knowledgeable and humble people that I know. And when you go to those kind of communities, it's amazing to see how similar thinking and similar problems we are discussing in multiple different ways and topics. Everyone also knows OWASP, but not everyone knows that besides the top 10 list, they have amazing resources that actually can serve as a good guidelines for simple testing inside your team. So for example, the web security testing guide has really nice step-to-step instructions, what kind of things you should test about web application. So you don't need to start from a blank page. You can actually use professional resources as your guideline and get the low-hanging fruits away from your system before you are involving highly paid security consultants testing the first level of the system. This was also present in the discussions during Disobey about category validations, that some organizations who are trying to get this validation fail in very basic things. So how do we raise the baseline by even using these publicly available, very well tested resources and make sure that we have dotted the I's and crosses and whatnot, and leave the really interesting, not so trivial problems and bugs for the security professionals to find. And yeah, Sans too. So not surprisingly, US cybersecurity scene has tremendous troves of good information, and Information Security Institute SANS has a really nice set of white papers you can dive into and find very good papers also regarding DevOps. As everyone knows, pipelines are these days one of the places where people are trying to attack a lot. Because if you can expose and infiltrate into the pipelines, you can basically then own the whole kingdom quite easily. So not going to spoil anyone's day, but that's how it is. So everything is broken, nothing is secure. Love your security people more, and does anyone have questions?
All right. Yeah, Vastime is a kind of a nice example to use any security presentation, but thinking about the company, so kind of IT was not their main thing. Of course, information security should have been kind of in their thoughts, but that overall kind of, well, when the IT is not the main thing in the company, you kind of then screwed up the whole thing. But thinking about the rest of us, so if we would just use common sense and do some basic things right, do you think would be pretty well off regarding security?
So yeah, security is not necessarily hard, but then again, you have to do the basic things properly. And one key thing to think about, which I had on the slides but didn't mention that much, how do you detect if you are being robbed? How do you detect if something that you don't want to happen is going on in your system? In physical world, we might see it quite easily. We might see that I don't know who those people are, and you might be able to do something. You might be able to stop them or call security. In digital world, if you don't have the capability to detect that something happens, you might actually know about the problems when the copycat product is on the market, or you can find your product from Alibaba for $5 per piece or something similar. So yeah, do simple things right. Be aware that whatever data you are trying to protect might be actually also compromised. Figure out where and how you want to build the protection, and also understand that all the protections come with the cost. You might be slowing down the business, you might slow down the creativity, or you might be accruing a lot of costs if you want to solve the security problem with a very, very expensive, very AI-based solution that doesn't necessarily solve anything. So it goes always back to the basics, and do the basics well, and you should be quite fine. After all, anyone can be infiltrated if they are willing to use as much resources as needed, but not many of us are that kind of targets. So based on threat model, prepare for things that are relevant in your domain.
Thank you.
Yeah, when I started my work, there wasn't really any frameworks, but we did everything from scratch, or companies did. You said that you cannot trust your data, you cannot trust your input or integrations, but many of the frameworks do the like validation of the data. But frameworks nowadays are like built from modules that have dependencies, that have dependencies, that have dependencies.
Turtles all the way down.
And at the start of the Russian attack, there was actually an npm package that attacked the user and removed everything from her or his hard drive. So can we trust the frameworks? What can we trust?
Yeah, that's a good question, and takes all the way back to the questions about pipelines. So depending on your security needs, there might be the need that all these dependencies are downloaded from trusted sources and cached locally inside your organization. And then there should be a vetting process to make sure that the next version is allowed to go into the pipeline. This comes with a high cost. So if you are doing like Node.js projects, there is somebody going through like a forest of transitive dependencies. But this is once again what you are protecting. How do you know if things fail? And this goes or produces into the discussion also the question of blast radius. So can you circumvent some of the problems in the system by having limited blast radius? In our project, we are thinking that, for example, some external file parsing is going to happen in disposable containers. So should there be some kind of bomb type of attack, it only destroys that container instance and can't be then causing problems anywhere else. The rest of the system will see that, okay, the container died, we can try it a few times more, and after that we quarantine the file and do not try it anymore. We are accepting like Excel sheets and XML messages, so yes, I'm enjoying that.
A few comments to Timo's question. First, it does, when internet is, there's easy targets all around. So if you happen to be the sort of the fifth slowest sheep in your category, so not the worst protected bank, for example, you'll be safer. And then another comment that you shouldn't trust yourself, and then it does give a limit to trusting others as well.
Yeah, adding on some comments there as well, Timo and the other side. So yeah, I think Timo's side, like as you were asking about the question. Anyways, first I'll just quickly introduce. Like I'm Man Singh. and I've been working into the security area, so cybersecurity area. So just wanted to add on some things. I think you all are a bit eager to understand these areas. So one thing to remember, that when you say that good enough, what is good enough, level? It all depends back to your organization, and I think there was a very good comment already that you have to look into the cost versus benefit. Security is all about that as well. At the end of the day, if your organization and your business doesn't do good, there's no security at all, right? So you have to look into like what would you lose if you happen to get robbed, as as mentioned earlier. What it means, will you lose the just one case, one customer, or the reputation of the organization, or what's on stake? So it's something which you should keep in mind, that what's on stake. And then I think the most important part is to do the things right way. As you already said, like, okay, if I do my job right. So it also includes for example, the secure coding guidelines, right? That's a kind of very much standard right now. Like everybody should follow, and it's not cherry on top of the cake, or it's just not a spices on top of the food which is ready already. So you have to do it from the start, from the scratch, and you have to make it embedded from inside out. And there you will have your answers. Like if you know that this is good enough and it matches my cost versus benefit ratio, and you are doing enough to meet their business requirements and as well as securing their future, you are there, like basically.
Yeah.
So that's one thing. That's what I was wanted to add. And then from your question, it was the second question was about the frameworks and modules, like they might have dependencies and everything. So few things what you should remember when you start any project, if you start from scratch, one thing you should remember that what kind of modules, and especially in this case, we are saying some third party. It could be open source, it could be proprietary. So you just have to make a choice, right? When you are making that choice, be very cautious. Do your analysis well there and then itself, instead of crying out later. So you should do your, let's say, soup analysis or proprietary software analysis much ahead of time before you even integrate and start using it. Then during the process, the very, very important part, don't leave it loose. Be proactive. Be vigilant of any kind of vulnerabilities in your software. So it's about these vulnerabilities, about these modules, that's the biggest threat you will come across, that they are outdated and they have vulnerabilities which are publicly known, but you never fix them.
Yeah.
So make sure that you really reach to that point, that you are making proactive efforts to fix those, so that your framework doesn't struggle with those kind of continuous and ever evolving attacks around the corner.
And regarding this, also it's good to remember that the computing environments are changing. So what used to be like secure, not connected environment might suddenly be connected environment, and people can move laterally in your network, and suddenly the old box, just like with the Equinox infiltration, is available for hackers to steal data.
Right.
There was one more.
Yeah, sorry.
So I saw your list of communities and resources. Have you heard about MISP?
No.
So it's this, some people call it social media of cybersecurity. It's an open source tool, and where you can basically track all the threats and basically any kind of malware around the world. So I was just thinking, have you heard about that and use any value to it?
No, I haven't heard about it.
So it stands for Malware Information Sharing Platform, I think. So MISP. And it's an open source tool you can install from the internet. And it's basically social media of cybersecurity. So it's pretty cool.
Cool.
Yeah. Yeah, it's rather, so let's say, hard to install in my experience, but that some companies use it. So let's say that there is some threat or some penetration of in their systems. So the company won't publish that. Yeah, this happened to us, but they might like hide themselves. So they have like a third party or something which publishes the thread and the malware and its contents on the internet. So beware of this, but it didn't attack us, or we don't even know who we are,
Yeah.
kind of thing. Yep, go ahead. Or
Yeah, not a question anymore, but want to answer to you that really good answer, and I want to share our tools, what we are using to tackle this. We are using Snyk in CI/CD pipeline to compare all the versions in CI/CD pipeline. And then we have our solution for SBOM, software bill of material, so we know what versions are running and where. And then we are also running Renovate. That's using the same global database as Snyk, but it actually does automatic merge requests for our developers. So it will update the dependencies. Developers just need to approve them.
There are still more questions, but should we have a break and continue discussions elsewhere on the corridors? Did you enjoy? Yes. Okay.
You are there.
Yeah. First a bit of a commercial break. So probably most of you have noticed already, but the DevOps conference is starting tomorrow. 2 days full of great speakers, free event online, go there. If you want to know more about the event, maybe some of you already know this, but one of the speakers is actually present here today, so you can go and ask him more about the event and his talk. Okay, but hey, next we will dig deeper into cybersecurity. So we will have Man Singh from a company where the security is not optional. Should I say so?
Yeah, not anymore at least. Okay, thank you, Timo. Yeah, so I think the idea behind is to give you a bit peek into. Yeah, I don't know. Is it working? Yeah, no. Okay, very close. Okay, so yeah, the idea is to just introduce you to this world, like this healthcare, medical devices, and show you like what it means to do the development there and what it means to have cybersecurity, deployed, and how do we take care of that. And I'll just try to go through. It's a little long presentation, but I'll try to go through wherever I can go with speed. But then I'll try to give you as much information possible. And then later on, of course, anytime we can have a deeper dive sessions as well in some of the topics. So I would be interested to do that. Yeah, so first thing first, maybe that person is me, if you cannot recognize. And that's what happens when you are in security. Like, that's the change you get. So
that's like a week.
Yeah, yeah. So every week it changes. So yeah, I've worked in different companies and different roles. As you can see, I have been a consultant once myself in Tata Consulting Services, working in the networking side, then into the telecom side. Worked as the developer, tester, scrum master, project lead, engagement manager. So I worked in different roles there. And then I jumped the ship to Nokia for the telecom side. I was there, the architect, and I was looking after the cybersecurity part. I was the product security lead there, and as well as system architect for serviceability side. And there, I also had a good exposure to the telecom cloud. Worked on OpenStack quite extensively. So understand the cloud stack, like how things work. mainly into the KVM side of things, not the other ones. And then I just had a bit of vision to get into the entrepreneur side of things, and then I jumped the ship and went into Kiva. It's still there. Like some of the partners, we just tried some hands into some area. They are really quite nicely rising company. Like they are into digital marketing though, so they have been doing quite well. And then I exited from there and jumped the ship to GE Healthcare. And that was really interesting because it has very different domain altogether from telecom, from networking or marketing. So it's like really very different. And that, I would say, taught me a lot of things in GE Healthcare, like how the health tech works, how the healthcare system works, and things like that. So I would say last few years have been really a lot of learning because of this health tech and healthcare area. It's highly regulated industry, which means that you really have to be on your toes all the time. You have not only the real customers, like let's say hospitals, your customers, but you have regulatory authorities as your customers. Basically, you have to really make them happy, otherwise you cannot enter the country at all. So be it US, like with FDA, be it China with NMPA, be it Canada, be it Brazil, anywhere, or even Europe with EU MDR. So there are a lot of regulations there. But let's go through what is GE Healthcare Finland. So the 700 employees written there is not the accurate one. Right now we might be over 800 employees. Most of them are into the production side. Like we have factory as well, which is again surprising thing, but it's really interesting that in Helsinki we have the factory in the office. Like we have 3 floors dedicated for the factory, and we make the devices here in Helsinki, and they are manufactured here. Around 29 nationalities, which is again really good thing. Like we have multinational, company tag, like a lot of nationalities. And as I said, half of them in R&D and 25% in manufacturing, and then we have a lot of health tech related patents as well coming from this side. Then there's the range to give you an idea, like what was it, and there is a history involved. Before GE Healthcare, it used to be DTEX. Again, it has a very big history with the Finland side. They have been making a lot of different devices, and in the early 2000s, it was bought by GE Healthcare because they had really good products coming from DTEX and instrumentarium side. And as you can see, this is our latest product coming from here. Like this is like future looking. This is wireless, as you can say, wearable monitoring system for the hospitals in the ICU or operation theater. But in this case, this is more like ICU and then the normal ward case. And these are really nice modern kind of screens and monitors for checking a lot of parameters, like patient parameters. So yeah, why does it matter? Like, I mean, why we are talking about it? It's healthcare, it's hospitals. Why should we care, right? It's just patient, just getting the treatment from the doctors. Why should we care about it? So I would say, taking from the global view, as you see, so cybersecurity failure is one of the top risks. Like from the World Economic Forum, also they have denoted as one of the very big risks in the coming future, and in short term, in long term, it's becoming really significant. So one has to really deal with it, and it will go more and more that one has to deal with it. And these are some cases, like these are old ones, but still matter. Like for example, these cybersecurity incidents can really do damage, some damage, like as I said earlier, it depends like where you reach. For example, it could just lead you to fines or lawsuits, or it can just bring a negative impact to your brand. And then there could be like this government sanctions coming in if you don't follow their rules. It could be customers or even patients there getting a risk, like it could be privacy violations. And then brand run is really a big thing. Like if you are a big company, it's a big impact. So you really have to be on your toes to be away from that. So we already talked about in our previous discussions, famous case was Tamo, although it was more on the privacy side. If you see, it was privacy of the people and affecting in those terms. And then these two cases, like one was related to the bank, OP Bank, as you can see, it happened, and then a very unfortunate event which happened early in 21, where the ransomware attack happened in one of the German hospitals, and due to that attack onto their IT systems, they had to shift patients or this specific patient to another hospital, and during that transit, the patient died. And as soon as the ransomware attackers knew about it, they just left. Like they opened the system, and they left, and they ran away because they never thought it will bring go to this side. So yeah, why? Like, what's the mentality part of things? And I don't know about the level of the information, the knowledge you guys have. Like there are so many of you, so I'll just keep it from the scratch, like starting from this part. That what is the difference? Like why we have to care as a defender? If you see from the attack side, like the attackers just have to succeed once, right? So they infiltrate once, and that's it. Once you're compromised, you're done. Then they will always try to find the weakest spot, and they can play dirty. They can do social engineering. They can rob you, put a gun on your head, and try to get your password, right? So they can do anything they want, and they have leverage of this zero-day vulnerability as well. As soon as it's out, they can really use it. On the other side, we have this trouble, really big trouble, that we have to make things right all the time. If you don't, you can be really attacked, and you can be compromised very fast. And we have to defend each and everything what we have, right? So all the interfaces we have, all the touch points we have, so we have to defend each and everything. We cannot be loose saying, oh, this doesn't matter because it doesn't interact somewhere. Just leave it there. This port is not used, so let it be there. Let's not disable it. So, so that kind of mentality, we just have to be really careful that we have to defend each and everything. And we have to play by the rules always, right? What's there in the standards, policies, regulations, we just have to play with that. And then we can defend only the known attacks, and that too known in a while, because you need some time to fix those and deploy on the field. So this is really, really, a challenging situation, because one can really use that to, infiltrate immediately. And we, on the other side, have to really be cautious that as soon as it happens, we have to find it fixed very fast. Yeah, so what are the expectations, especially from the medical side, medical devices point of view? I'm thinking, what should be the customer, what are customers' expectations are, and we have heard many times from them. So what they want, if you see, what they want is, protect their patient and their privacy data, right? So that's the prime goal they have. And to achieve that, we have to really take care of many other things, communicate about the vulnerabilities as soon as possible, provide and keep the CBOM, which is SBOM, you might be knowing, bill of material we have been talking about, and then disclosures. So we have to be aware and give them very fast and as soon as possible the compensating controls or workarounds or whatever we have. And then also we have to be vigilant on managing the incidents. So there could be a lot of different incidents happening on the field. So you have to really manage and see like how do you handle those. And then also it's not only about you, because you might have a lot of stakeholders involved. For example, you might have contractors, subcontractors working for you. It could be, in this case, let's say there's a hospital. So hospital have IT staff, hospital has clinicians. They all are stakeholders. They all need to get educated, right? And then you have your own field engineers, your own service engineers working there. You can have contractors who are working as service engineers. So you just have to be sure that you bring all on the same plane and make sure that they take care of security side seriously. And this is just to give you an idea on the regulator's point of view. On the left, very left, you can see it's pre-market regulation or guidance document, wherein when you submit to the FDA, say, okay, we want to really enter to the American market, we just need to really have these things covered, and we have to really follow through the guidance. So many things you can see very common in all areas. And right side is EU MDR, which is EU medical device regulation. So they also have become very, very active nowadays. They used to have EU MDD, but now there's like a EU MDR. So you can see very clearly the topics like secure by design, security risk management, risk assessment, life cycle assessments, aspects, and post-market surveillance. So you'll see a lot of things like happening around, and you really have to take care of all of this from start to end. And we talked about this kind of security framework. So these are very popular, risk management frameworks or the security side frameworks. One NIST is very, very popular one. So there are a lot of kind of frameworks underneath, like inside NIST. You can talk about like there are so many different ones. One is RMF. And then we have, for the medical devices, we have this 14971 ISO, which is really the kind of Bible for the risk management. And there is a collaboration between this cybersecurity risk and then the risk management in general. And then you have this 8001 or 80001, again, for the medical devices on network. So these are some of the kind of frameworks that you can use. And this is the idea, and this is a kind of standard template on the left. As you see, this is how the medical development works. Like you have to have a design plan, design input, design output, design verification, design validation, design transfer to their production side, and then you have post-production. So how do you deal with those? And those can translate into, if you see, this is what happens like at the very start from the input and to the output. You should really try to map like how security comes into picture. From product requirement to security requirements, product architecture to look into this security architecture and security implementation, and then also do the risk assessment from the security perspective. So this is something which is a kind of a pure template that one has to follow with this. And this is how it works. Like, this I just try to make like how we work like in general. So on the left side, if you see very start, it's the concept time where you haven't done any coding, nothing, no development, nothing. You are at a very early stage. And what do is you try to find out the security controls and requirements that would be required for your features or for your product. So if you have a new product introduction, so then you have to think from the product very high level, like what are the requirements and controls that you can take. And those controls can come from NIST. For example, NIST provides really a big set, like almost 1,000 different controls. So you might have somehow bumped into those many times. It will be like identity management side, or it could be configuration management side, or it could be remote access side, and a lot of controls which it talks about. And for that, with that, you do the base profiling, and then you try to design for security as well at the early stage, and where you can do this threat modeling and risk assessment. So I recommend everyone, as already in our previous session, it was clearly mentioned that threat modeling is a really good tool to really understand where you stand, what are your exposures, where you can really tap like and what are your, for example, external interfaces, external path, external flows, where you can put some of these controls. And then, of course, comes the development part where you have to do the code review and the static analysis. We have been discussing about it, that this is really, really important as well. And here, I would suggest, even here, what we do, we have this path where we need to have the secure coding guideline or secure coding training. So there are really good materials even available like in LinkedIn Learning, or you can say like so many places that there are secure coding, I would say, classes that you can just recommend in your team, telling like, okay, let's have this and do this session and understand like what are the best practices for secure coding. And then you have static analysis done at this phase. And then when you go further into testing side, then comes this dynamic scans like desk tools and others come into picture, where you can use those tools for finding out do you have any vulnerabilities and issues in the system still? And if yes, then you try to go back and fix them and then run them again. And then you should have a proper documentation as well to know where you stand. You can have this privacy security manual kind of document, or it could be in many terms, like many places they use security hardening document, or just about cybersecurity architecture document. Like depends, like what you have, you can have extensive and more comprehensive data there. And then never to forget this part, because this is the traveling part, the real life of the product. Remember this, that real life of the product starts when it's in customers' hands. So we really focus a lot here, do a lot here, but we forget this part. And that's where we have the trouble, biggest trouble. So we have to be vigilant and proactive in this phase. And that's what I would say that you should be doing, and trying to see that if your products don't have, this is something which you should do definitely. And these are most common security risks, like high level, but there are like many of them, but I just listed some. Like, you could have this kind of inadequate protection of data. Yeah, right. So it could be that your data at rest is not encrypted, is one way that you have to really be careful that you don't keep your data just like that unprotected, because that's your biggest asset, right? So you have to protect your asset, or while in transit. So it should be protected while in transit as well. So you should really protect it. You might have lack of system hardening. You haven't hardened enough. You're just letting, let's say, telnet, to your system. If you have a device, like depending, like the software product or the hardware product, like depending. So you can have different ways, like the insecure interfaces, physical or logical or virtual, whatever interfaces, if they're insecure. And then insufficient malware or ransomware checks and things. So yeah, I mean, these are just the common ones. I think you already know many of them, but it's just to reflect. Yeah. So viewpoint. So I would say like one thing you have to remember is like it's integral part, and that's where we have the problem that we or I don't know, it's the company mindset, depending what's the culture inside, that they tend to see security as on top thing, like spices on top, or as I mentioned, like cherry on top of the cake. But it's not like that, and never go with that mindset. And try to change the mindset of your colleagues, of your leaders, of your managers, and you can do it. Like you can do it yourself. I mean, you don't need to depend on anyone else. And then as I mentioned earlier to some of you, that I struggled earlier with this, and it took me time, but I educated the people inside in different cross-functional teams, and then I took them to that level that, okay, they understand this is really important, and then brought in external parties to really educate, in the sense that give the sessions and tell like how important it is. So one has to really change the mentality and mindset of the whole team and cross-functional teams. So in this case, like as I said, like from the medical devices point of view, patient safety is the key. Like we really have to think a lot that whether somehow, some way, we are impacting or we are bringing some hazardous situation for the patient, and it's really, really important because we are talking about our life. And this is what we have to remember always, that this is our customer, right? So we have to really be cautious that we cannot take things like light. We are talking about life here. And then we have to really go through that path that we take each and everything what's happening to that level. Yeah, so, and as I said, like business requirements are really important, right? If you're doing security for fun, it's not bringing anything, right? You might end up breaking your systems and it's of no use because you can do a lot of security and then break your systems. It doesn't bring any value. So what you do is for your business, right? So in this case, as I said, it's medical devices, our customers are patients, and patients are critical for us. Their safety is critical for us. So that's how we run everything. So business requirements are important. And that's where these regulations come into picture. As you can see, HIPAA is for the privacy side from US. And then we have the FDA regulations, NMPA, UMDR, as I told. And then we have to follow a lot of different standards and see that are we there with it. If not, comply by it, but we are following it some way or the other. So in this case, there is UL 2900-2-1, which is for medical devices. It's a really good one, which gives a bit of guideline. 62304 is for lifecycle SDLC, like software development lifecycle side of things for medical devices, medical software. And then 27032 is our normal information security, like all 27,000 series is like all related to this IT information security related. And 1497, I said, as I said, was for the risk management side. And then we have some policies as well, like NIST provide policies like FIPS 140-2-3, and then we have our own GHC related policies as well. And this just to give you a glimpse, what I was talking about earlier. So we have FDA, we have Health Canada, we have NVISA, we have CDSO, India CFDA, which is NMPA, and then we have MHRF from the side, then we have Swiss Medic EMA, which is like this EMDR and MDT side, and then Japan and Australia. So we have a lot of, and then South Korea, Singapore, they all also have their own. Yeah, so what do we go with? So we have this overall software development process, right? So there is this process running, like as you can see, there's like very kind of a trivial one, but this we have to follow it with the letter. Like whatever is there, we have to really follow and showcase that this is how we are working on. And this is from the IEC 62305. Yeah.
Looks very agile.
Yes, very much. But interestingly, actually, if you can break it down into, yes, like this works there, like, but we are having agile as well. But yeah, but this is coming from the standards.
Who follows that you follow this?
Yeah, so it's a very good question. Yeah. So in the medical industry, or the I would say healthcare and health tech side, so we have a lot of different functions. One function is called quality affairs, and the other one is called regulatory affairs. So quality affairs, there are quality leaders, lead engineers, leaders who are constantly looking into like how we are doing and whatever evidences. So they have to really, they will check and go through each of the evidences. When we do the programs, one has to check and go through those. And then we have this kind of mock auditing, which meaning there will be auditors coming in and checking this. But then there will be real auditors, like it could be an audit from FDA. So FDA, suddenly someone from FDA will come down and say, oh, we want to come down this time, or let's have it. And then there are notified bodies. The notified bodies are someone who are notified and are kind of recognized by the regulatory authorities, like EU MDR has one notified body. Let's say, as an example, Eurofins is one of the notified bodies. So they can come and they can audit and they can just go through like everything and say like, okay, are you like you have some deficiencies here, so you have to really fix this. So yeah, so there are many mechanisms. So they will make sure that you are following this. So yeah.
Take this is still on. Yeah. Just a comment about the agility, because I've been there in the R&D and it's kind of on the kind of smaller scale, it's agile, but in practice, I mean, looking at this picture, what this picture means here, that you are not releasing software every day or every week, or maybe not even every month, at least if you're making a kind of big software release. Maybe some updates can come even weekly if they are urgent. But in practice, what happens there is that there is clearly separated development phase and verification phase. And kind of anything you release has to go to the verification by the book. End of story. There is no option.
Yeah, thank you. Yeah, and similar thing happens for the post-market software maintenance process as well. So one has to really follow. But anyways, I wouldn't go deep into this. Like you have been doing something similar already. You know about that. But then the important part is like, how do you do this kind of validation? Like one has to really identify the potential weaknesses, and then you have to really include the test plan and do the testing in such a way that you're sure that you have those requirements have been met. And for that, I would suggest that one should really look into things from the non-functional side of things for the security. Always try to see like if you can make some negative requirements. If not make, but then you can take into your head that okay, there should be some requirements which touches this negative part of things. And your tests are risk-driven basically. And this is one example. Like I've just quoted here, that production will not allow changing a password back to a default password, for example. So this is one kind of a negative requirement you can see not there, right? So it just makes sure that somebody doesn't, forget to check this. Otherwise, they will check, okay, these are the ones they are working, like from the left side, all passwords shall be able to be changed. So you just check that, but you never check like the other combination or other possibilities. So keeping this mindset is really important from security viewpoint when you do the testing and verification or validation part. And always check for unexpected behaviors. You should, and there can be something deeper and bigger happening underneath. So you should really look into that. And these are the different phases that, like I would have, talked about that. On the left side, like as you can see, the top one, the very first thing what you should really definitely look into is the threat model. Like you should understand what kind of product or feature you are into, and then do the threat modeling on it. And that will really expose and tell you like what kind of requirements you might get in, or what are the deficiencies in there, and you can just really take those out. And then of course for the medical devices we have a lot of other things, like I've just noted that you have to just check the processes right, like the process review, then the standards, and then also about the regulations and policies. And then on the developer side, like when the development happens, like definitely have to have code review, unit testing, code static analysis. These are really important. So I would say one should really do things as early as possible. Like unit testing, if you can really do extensive and as much as coverage there in unit testing, you have really lesser and lesser chances of getting something here down this side. And I have like seen many examples to tell you, like in last many years I've seen this like so easy. Like one example, simple example is data validation, right? So if you are able to validate data already there and check like when data flows, how you know what comes and what doesn't, you are able to do that early enough, you won't fall into trap here at the very end. And then of course you go into the functional tests, like put the functional tests, and we are talking non-functional, wherein you should do the testing, positive tests for security and negative tests as well. And then of course your penetration testing, and then this dynamic scanning and dynamic tool usage. And these are some example sets, like, for example, this Microsoft threat modeling tool is open source, although it says Microsoft in front, so you might not guess that. But it was started in Microsoft, but then they outsourced it many years back. So it's like there available, and it's a good tool, like it does what it needs to. And then there are many others, like I've just like put some of them there. Okay. Yeah, in unit testing, I would say, again, the mindset with the negative requirements, like you should really think from the negative side as well. And it should be kind of a developer's own mentality that, okay, they have to check both sides, like it's not behaving the way it should not. And if you can check that early, and also you can utilize so many frameworks for all different languages we have. So it's possible to use there and put as much as coverage possible. Yeah, for the static application security tools, many of them, I gave the example, we have this Coverty, the top synopsis Coverty tool. Gives good indications, but not the only thing which should be used, but this is really good, and we have this kind of running all the time, and we see and analyze like what's there. The developers, the teams do that. And then again, as I said, like from the standards and regulations point of view, we have to have the evidence, and we cannot have any risks coming out of this as well. So we have to really look and see that if there are any errors and issues, have we really checked onto them. And then in the integration, and this is a term which you will hear a lot, defense in depth strategy, and that's really important in security, as we already seen that everything is broken, right? And that's true, like it's broken. So you have to go with that mindset and put layer by layer, so that if one layer is broken, it doesn't mean you're fully compromised. You can still work on it and bring it back. So it's important that you think from the defense in depth strategy. You see many layers, like starting from very first interaction with the interface to the backend, to the to your servers or whatever you have. And then it's a good idea that if you can simulate the real attack scenarios. And it's a good strategy that there are a lot of different simulators, and you can make your own, and then just even do a exploratory case. When you have done the integration, try to play with kind of negative values, negative things, try to stress the system through many different ways, so that you are able to get through and see that, okay, we are able to catch through. Like, I think input validation is one of the very common ones where we have the issues many times. And then going with this dynamic application security testing tools. So there are many in the market as well. One which is quite famous, the second last, Tenable. It's like enterprise version, like it involves money there, but it used to be this Nessus, if you recall. Nessus where like versions are available. For example, with Kali Linux, you can get this Nessus and burst suite and everything there inside if you want to do your own without spending too much of money on it. But there are so many of them. Burst suite, for example, the third one, is really good for this web server and web application testing. So I would recommend that burst suite is something you can really look into. Yeah, and then penetration testing. Yeah, it's a good thing. Like if you have a skilled partner, or if you have a skilled team inside, it's a good thing to do. Give it to someone who doesn't have the idea earlier, or have the idea but is skillful in understanding the security concepts and understand like how to go through. Of course, it's a very specialized field. You have very special, you need a special skills to do this penetration testing. But then it's also exploratory in nature, meaning it's subjective. So it takes a lot of toll. Like you need to really think a lot, like how one can really penetrate through a system or device or software. And usually you can have it in gray box, white box, and black box. And I said black box in a way, in a broad way, basically. But we have this white, black, and gray. So gray box and black box is the very common way of this penetration testing that companies do. And we also do this with the third party. So that's how we. Yeah, so there's like the definition of what it means basically. But you know, I think many of you already know. Yeah, and this is something which you should definitely remember, right? So software engineering developers have this mindset, right? That they just try to ensure that, okay, certain things work the way they wanted it to work, and they just forget after that. But that's not it. What one should do definitely is that they should ensure that it doesn't do what it's not supposed to. And that's where the security starts. And that's how you have to see. So you might have seen like not and don't and everywhere. And that's why you see the security guys being very negative about things. So it's like you have to really see from many different perspectives. Okay, that's it from my side.
I was just thinking, since you mentioned that for unit tests that there's the coverage matters and so forth, and I've seen a lot of like excellent coverage, no assertions. So that's a thing that happens. But have you tried mutation testing to verify the tests and especially in the sort of security aspects, whether it helps there?
What was it?
Mutation testing. So you mutate the code and see whether the tests would catch if the code is
Yeah. I think we have done, like I would say not in all the modules, but I recall that we have done in some areas only. But I wouldn't say that we have been doing it extensively. But then we have this kind of really interesting tests as well, because we are talking about the physical device, right? So there are those kind of cases. I think I did talk about that as well. It's a little different from the mutation testing, but it's about the fudge testing, wherein you try to fudge the system and the interfaces with different kind of inputs and try to see what happens. So we have this kind of inputs coming from different sources, like it could be a barcode reader from the patient, right? So it's an input coming from there, or it could be some knob or some kind of small keyboard or something. So we have this kind of specialized tool, specially crafted tool to do this part, where it just tries to do it on the screen and tries to do all different fuzzing. But then the same test is also, not same, but for the interfaces, it's done by penetration testers as well. So where they try to do like really extensive for each and every interfaces, be it RJ45, be it USB interface, be it even specialized serial port or whatever.
Yeah, I know fuzz testing, and the sort of mutation test is that you modify the software. That's how you get a reading on how good are your tests.
Yeah.
So
yeah. So there is like
worth a try.
Yeah, exactly. And I remember that one team they have done, but then I know that others have not ever.
Hello.
So yeah, thanks.
Yeah, I was just, before you said that, I was going to say as well, because I worked in some medical projects trying to introduce, DevOps, and it was quite difficult. And we tried mutation testing, but we used it as a way to gauge how effective the tests actually are. Like, are we just testing or are we actually asserting? But we did fuzz testing as well, and we had somebody come in, specialist, and do that. And like actually, when I arrived at the company first, we sat in the same room as him, and it was really fun because he was just like, it's like, I found something really interesting, and we're like, oh, what did you find? And then we just had no idea what he told us, but yeah, that was cool. But yeah, I found that so I was kind of in the middle. I was trying to help software teams to do sane things whilst keeping the configuration manager and people involved with regulatory stuff still interfacing on the software side kind of happy. And I really found like a lot of the time it's just like we're miscommunicating so much that what's written in the standards and what's written in different regulations and so on, if you just tell a software developer in their own language what needs to be done, and you need to produce like traceable code, you need to have objective evidence that these things have been done, and we need to have that available. So if there's an audit, we can generate a report and serve that. then a lot of this kind of craziness goes away. And I haven't been in the space now for maybe 4 years, but I'm really curious, like, how, is that sort of, does this resonate with you, and do you feel the same, and has it changed?
Yes, I would say still it's, as I said, like it's a highly regulated industry, and a lot of things are coming as a legacy, right? So many years somebody has worked and the processes have been made like 10 years old, 15 years, 20 years old processes, and that's where these clashes happen a lot. And I happen to be in the crossfire many times, as you were saying, that many times, it's not like one time. But yeah, there is a bit of shift that they see, like from the cybersecurity side, I can say that there has been a shift, and that shift has happened in last few years, not before that. Like last few years it has happened, and I had to push a little harder on that part. And then also the pain, as you said, for the developers, yes, there could be this understanding, like, coming from the standards and breaking it down to the thing which they can really understand. And that's what we have been working internally, that we break it down, try to break it down to the level that the developers can understand, their team can understand, PO and Scrum Masters are able to understand what is going or what they want to achieve out of this. So breaking it down really. And in some cases, yes, it's still a same trouble, that there would be like kind of a understanding as well, and the miscommunication. So it could be from their, let's say, product managers. We do have the product managers, they're thinking of selling the thing, idea would be different, and they would go with some features like, let's say, security features, or they talk, oh, we have this or that, and they understanding, they didn't have the right understanding that what really we kind of claimed and said when we adhere to certain policies or standards. So there is still that part, but I would say it's getting better, but it's still, we are not there, that, seamless, that coming like directly written in stone, like, okay, this the standards, or this is the part, and it should translate into this exact feature, and this is the sub feature, and this is how it should come out as a requirement and go up to the test plan and testing and evidence, like objective evidence side. Yeah.
Interesting.
Hi. I also come from quite a heavily regulated industry, so I was kind of glad when you mentioned, this is sort of half comment, half question, I was glad when you mentioned culture. And I'm sort of just wondering out loud, like, how do you build a good culture of security? Because heavy processes don't motivate, like long release cycles don't motivate.
Yeah.
So I mean, I think it's quite easy to get people like excited about security the first time, but how do you keep the momentum going? Like, how do you keep people excited about security?
Yeah, I think there are many ways, and I had, as you really caught that I had a struggle, like really bad struggle, like a few years back, because there was a resistance, like very big resistance, and I think maybe not from the developers that much, or the line there. Maybe they didn't know about like how they can really go about it, and it wouldn't change much, but their mentality has to change. But biggest challenge was with the the leaders, managers, and those QA guys and others. QAs, especially with the quality aspects, they always say, okay, the processes are written in stone. Like 20 years back, they were written, and they are still written there. And I remember challenging that, and interestingly, I was able to put few new processes in place. So the idea is, I think, many times the best way is not to kind of just complain, but then rather go with some solution. That's how I did it. That I went ahead and said, okay, we need to have this kind of process here, and that will replace the older one, which was really heavy, and you just bring it to the lighter part. So you just have to own it for a while, and then pass it on to someone else. And then at the same time, motivation part, I think what I did, at least I was taking multiple different sessions of different topics, and I was amazed that from my team, like always, there were like 120 people, within team each time, and it was like they were there, like to listen to it. And then I started after seeing that, I was inviting the external parties. So I brought in a lot of external speakers to speak about it. and people were really excited, and that changes the whole concept, because sometimes they are inside that small well, and then they cannot see like it's something important outside, and the world has changed a lot, and that really changes things. So I think we have to bring those kind of different aspects into it, and then of course depending on which industry you are talking about, I think one has to also see from like if it's a highly regulated industry, I think it's a good thing that you bring out the regulations as well to them, like if we have to there, like, because that's our motivation. Even if you tell to your developers that you are doing things in vain or non-value, they will just be like, oh no, how is it possible I'm doing like that? So you have to really bring that aspect that, okay, if you put this regulatory or standard part of things, you are really not going to do rework or do something or miss something and down the line. So I would say like there are many different aspects, but at least in my case, like I was able to, it might be a little different path for you, but I mean, there could be ways that you can just try to maneuver, but the thing is you have to initiate, and I was struggling at the start, but then I followed this path.
Business question, actually. You mentioned nicely that the security starts from business requirements. What's your experience and take on how to quantify risks, how to have some kind of dollar, euro, or yen value for unmitigated risks? Any good tips that people outside GE Healthcare could use?
Yeah, that's like really very difficult one each time. Like, I mean, it's such a subjective topic, yes. But then there are different, I would say, metrics, and from the requirement point of view, I would say the ways, again, the negative thing, but you have to remember, and that's how I see, and when I have made some of the business cases where I was pushed down that, okay, you should not take this feature in, or we should not do this. So the thing is doing it or seeing it from the reverse side of things, that what happens if you don't do it, basically. So the point is, if you happen to, let's say you talk about a feature, security feature, if we don't implement it, and let's say it's going to cause really big vulnerability issue, or it could be a finding or any issue, what kind of damage it can bring, and that can be calculated in terms of dollars, and it could be rough estimate. And I have done those in some cases where I have told like the reverse, like if we don't do this, what happens? Doing is anyways right, but then this is the part, and the other thing is about the metrics part, that you can sometimes easily motivate the leaders and management through these metrics, and that's what they love usually. So the best way is you can make a compliancy kind of sheet or metrics, and you go with that and show that you really have to comply with this, and then if we have to improve and make it better over a period of time, we have to pull in these features to really reach to a certain point, maybe 95%, 90% compliancy. So those are like some ways that you can really affect, because I would say leaders most of the time, they understand numbers a lot.
I'll try to.
Yeah, a totally different question. You said that you have a lot of governance standards and policies, and thank God for that. You have a lot of experience. So let's say if you would be a hiring manager, which kind of qualities, characteristics, or skills would you look for, or are different if you would be hiring in health industry, or let's say Kotipizza or Volt?
So because, from the security point of view.
Yeah, because it sounds like your industry, you need to be like a superhero or something.
Yeah.
That was a compliment.
We all are superheroes in our, we should just. Yeah. So yeah, I would say like there are very basic ones. Like I believe your question was about skills, basically, the personality skills, or what do we like? Yeah, characteristic of a person like whom we want to hire, right? So, and it could be from any other. Like I think the basic is very clear. Like, and I have done interviews as well, and I have hired like security perspective like guys here. And the most important thing I would say, like there are very like soft, like I would say soft skills are really, really important. And you will judge and see like it affects a lot, especially when you are into this kind of security landscape. The very first thing I would look into is this kind of, one thing is the curiosity part, like the person has to be really curious, like in nature, like when you put something in, they really ask questions and they understand the problem and they try to really solve it. So many times I have been putting some kind of those conceptual questions to those. And then the other part is the learnability, because we have to evolve each time, and you have to really come up very fast and learn and with new technologies, because the cybersecurity goes along with the technology, so there's no escape. So one has to have this learnability to learn fast. You tell something, they understand the concept fast, and they can respond to it. So that's really, really important from the soft skills point of view. And the third one, very, very important, is the communication. Because if you cannot communicate well within your team, and most of the time you are in that situation where you have to communicate with different stakeholders, and security is the area where you have to communicate with different stakeholders. So it's really, really important that you are able to communicate right thing at the right time to the right people. Like it's really, really important. Like you really have to nail it. Otherwise, you will give a wrong message. So the communication, learnability, and then this curiosity part from the soft skills. And from the tech skills, I would say depending on what you use underneath, I think it's good that somebody, like curiosity part comes in as well, that somebody is using different platforms by themselves. It could be their hobby, it could be something that they are really trying to understand certain platforms, like this, let's say OS, different OS, like it could be Windows, Linux, or whatever distributions. They're trying to really learn and get hands into it. Like they are ready to do their hands dirty and try to understand it.
To make it simple, would you hire someone straight from school?
Okay.
So that I would still feel comfortable at hospital?
Yeah, okay. So from the hospital, like, okay, now, because you had the question, maybe I didn't understand it. Is it for the hospital itself? The point is, even if you are a new hire, in this industry anyways, there is a process that you have to go through a lot of training material, and there is a set role and things and trainings for it. Like I remember when I joined, and like within first month, like it was like 77 trainings, and I believe Timo would have done a lot as well. Yeah, so it's like you have to really go through and pass all of them, and then you might have to, or you have to repeat and refresh each time. So even if you're fresh, it's not a problem, but then you will be assigned to a role which doesn't directly harm the patient. So that's how it would be. So it has to be really in that, and it would be a mentor and training process as well. Like I did some hiring and I did a mentoring, and it took like more than 6 to 9 months. So it takes a while because it's an area which really requires a lot of hand-holding and trying to tell them a lot of different things. And then it takes over 2 years to reach to a certain point. And then, of course, it's a different story. And you want to become expert, then it takes many, many years to reach there. But yeah, those are the cases. Yeah.
More of a comment to the, I'm in a highly regulated things. So you lucky bastard, because that's what makes it easy. It's like, you can tell the teams that this shit is never going away, and I'm the person that makes it easy for you. Love me, please. So that's, but then in cases like the Vastaamo case, for example, you can see that the security risks are kind of the absolute in nature. Like take any company whatsoever, prevent banking for 2 months, and let's see what happens. So that's how security is really vital and brutally necessary for everybody.
Yeah, in this kind of highly regulated industry, how much do you see content that the regulators have had the kind of good intent, but in practice the things are something that don't improve the security at all, but just create some extra work, extra documentation?
Yeah, that's like, yeah, it's a kind of a devil in that form. Like, yes, I would say, yeah, it brings something extra. But as I said, like, I'll bring it back to the case that we have to defend everything, right? The attacker has only one. So the point is, whatever it takes, you have to do it. And then, yes, regulators' way of seeing things is through documentation, right? There's no other way they can really peek into and get into things. In some cases, some regulators, they do the testing as well. It's, for example, in China, they have some certain kind of testing they do on the devices, but not all regulators. The only way they can see it through is via these documentation and objective evidences. So it has to be produced for that purpose to ensure that you really followed the way you said you followed. So it's like kind of really unnecessary devil, basically. And yes, yeah, it becomes very demotivating for the teams, I know. Many times, like software developers really hate documentation, I know. But at times, it's a kind of a necessary devil that you have to do it because of this case that you have to produce it. And then the content might be really less, but then documentation might be big in some cases. But yeah, I think there is some automation things has to happen, and I know there are ways to do it, but then for the regulation, it's a bit tricky that you have certain processes and certain templates that you have to follow and you have to go through it. So yeah, yeah, I agree. Like there are those kind of gray zone cases as well. There are, yes.
Yeah, just an interesting observation from that question and what was mentioned earlier, because my experience is that, well, like I said earlier, like you can communicate what you need to do down into like real things that you can do, and you can do, you know, continuous delivery and, you know, nice stuff in medical. But there's always this, like, people always like, oh, but we're regulated. And like, yeah, sure, like you have extra things that you need to do, but I wonder if there's a correlation of people moaning about being in regulatory environments and not being able to do, you know, all the cool stuff, and also people coming along and being like, you have to do this because it's part of the regulation. I think it would be a really good shift in a mindset if you actually found meaning to most of the things in regulatory compliance, not just do this because it's regulatory, but like,
yeah.
Because at least I haven't heard of a single thing in the regulatory guidelines that are like nonsense. It's always like mostly common sense. There might be some edge cases and gray areas where you're like, yeah, this doesn't really affect us. But at least my experience with the medical regulations as well is that you can always, it's not like you have to do this. It's like we like advise that you do this, and you can kind of talk your way out of it. I worked with a colleague once in Sweden who made a case that you could argue against using the seatbelt in a car, because if you crash and the car catches on fire and you need to escape quickly, the seatbelt might prohibit you from doing that. So therefore, we don't wear seatbelts in our medical company. And okay, this is a little bit far-fetched, but like there is flexibility. I always try to be an optimist and yeah, just, I don't know.
Yeah,
It wasn't really a question, just a comment about the correlation, people sort of moaning, and then at the same time we're like, you have to do this because it's regulation. I'm pretty sure there's a correlation there. Like,
I think that's a valid point, and there are side tracks. For example, we have this kind of hackathon thing like regularly happening, which is like kind of gives a bit of path for the developers to do something cool and different, and even in some cases that has come back into a way that we've pulled it into the software and into the development side as well. Yeah. But yeah, one, as you rightly said, that the mindset wise, it should not be that because it's set there, so you just have to do it. Most of them, yes. Many places there are guidances. Some are really strict, kind of rule book, but some are guidances. But then one has to really, see through like what kind of balance you can bring. And it's difficult. I mean, it's always difficult because you have so many different set of people and different stakeholders. One could be from the product managers, might have a different view into things and towards the customer, and then you might have quality might have a different view altogether, and then regulator will have a different view altogether. And developers doesn't know, and they do it in a different way. So yeah, it's a kind of a balancing act and difficult one at times. Yes. Yeah.
All right. Hey, thank you, Man.
So a quick message, still one presentation to go, and I guarantee it's not only about security, so you will hear something interesting today. Before the break, one thing that I want to mention to all of you, first of all, a shout out to Mr. Marko Janu, who made this possible, because in the last event, Timo mentioned that they don't have a host for the event, so we just messaged Marko through Slack, and Marko was awake, and he said that yes, we can do it, and he managed to get the budget and everything so that we have the refreshments here. So my tip regarding your companies and environments is that cultivate the relationship with the people who might have the budget if ad hoc possibility to host a good meetup comes, you have them on your phone or on your Slack, and they are actually willing to receive your messages. Because these events are totally worth it. For organizers, for participants, I absolutely love these connections. Marko came from Oulu, not only for this event, but I would say that mostly for this event. And he is also building the network around Finland for things in Siili. So if you have connections elsewhere, talk to him. Do you want to say something, Marko, to the community?
Yes, thanks for all of you coming here. This is a great event. We still have, as Heimo said, we still have one presentation left. But all in all, I like these kinds of conversations and presentations, and this is particularly this time. This is very close to my heart. I've been involved with the software compliance like 10 years already, a little bit different view, not just the security, but it is coming to the same area at the moment. So very important things here, and I enjoy this a lot, and thank you for all of you coming here, and let's see how is this going in future also in this perspective in Siili and DevOps meetups. Thank you.
Yeah. So let's have a break and continue with the last presentation.
As organizer, I want to ask from the sponsor that, are you hiring?
I think so.
Yes, of course, all the time. So I'm not so presenting here, but of course, if you have any colleagues you want to come to Siili, so you know what to do.
And so the last presentation now for something completely different. I don't say if it's more interesting or less interesting than the cybersecurity things, but let's just find out. So Jacob Lärfors and managing a platform as GoCode.
Thanks a lot. Nice to be here. So we've just had 2 talks about like not doing things and how to restrict things. And I'm going to talk about just creating stuff with care, but at scale. So managing a platform as GoCode. So I've been involved in a project now for about 6 months, and I got kind of brought in, and then things didn't pick up in immediately the direction they were supposed to go. So we had a bit of free time. So we used that free time to do research and think about how we build a platform, maintain it, scale it, and these sorts of things. And by platform in this case, it's mainly going to be cloud architecture and Kubernetes clusters, because that's what we've been building on top of. And it's Go as in the programming language as well. So I was trying to think of a subtitle, and my colleague just said enough with YAML, and I was like, good enough. So I think I'm a bit tired, and probably everyone's a bit tired. So it would be really good if maybe people ask questions during the talk, because this is probably going to be a bit more like brain power using than the two previous talks have been, which were very yeah, not to demean them in any way, but yeah, you're going to look at code and think about things. Anyway, so my name's Jacob. I'm consultant and CEO of Verifa. We're a small company doing continuous and cloud things. As a person, I'm nationally confused because I've lived in Finland almost 10 years, and that's the longest I've lived in any country, almost. But I don't feel very Finnish, and the other places I've lived, I don't feel very at home anymore either. So I'm pretty opinionated about stuff, but I'm also thinking I'm open-minded. So I like to hear other people's thoughts and views. And the goal of this talk is to challenge the norm. So I've been working with cloud architecture and various things for, well, not that long, because it hasn't been around that long, but like maybe the last 5 years have been pure cloud containers and Kubernetes, and before that a lot of CI and a lot of Jenkins and a lot of this stuff. And I was very against the doing things as programming languages. Maybe not very against. I was against it because everyone I spoke to who talked about Pulumi and CDKTF coming out and all of these like other ways of doing infrastructure and stuff as programming languages could never really give me a good reason why I should be interested in it. It was like, yeah, you can replace HCL with code, TypeScript, or you can replace YAML with Python. And I'm sure there's merit in doing that. I'm sure there's good reason behind that, but nobody really like compelled me to do it. So what I would like to do today is to try and compel you to look beyond YAML and throwing more tools and more things on top of the stack, and well, hopefully it's interesting. I won't get offended if you say this is rubbish. I'm gonna throw one more operator on the stack. But yeah, structure of the talk will be I'll go over the background and problems. Hopefully they will all be obvious to you. And then we'll talk about some of the hypotheses that we came up with. We didn't really do this very formally, during the time. So this is a very formal write-up of what we actually did. I mean, we basically just, got together and came up with some ideas and started hacking. And we're like, oh, we like this, we don't like this. But that's the research part. Then what we actually ended up doing, and then I'll talk about some of the future things as well, and kind of like where this could go. And a big disclaimer, this is not in production yet. We feel really good about where it's going, and it will be in production soon. And we don't really know like where this is going, or like we don't have much experience doing this. So if people have ideas, please tell us. If you see we're doing something wrong, then please tell us, or tell me, because I'm here. All right, motivation. So I'm going to probably point here. We've got a dude, it doesn't really work, top left, we've got a dude who's going to write some YAML and some HCL into a Git repository. When he pushes that or whatever, there's going to be some automated system. Doesn't have to be CI, could be Argo and Flux or something that kicks in. The YAML it might take and run through Customize, which does some overlaying stuff and then passes that to Helm, and we get a whole bunch of more YAML out the other end that gets sent to a Kubernetes API. And we get some objects created that refer to some maybe config maps, some environment variables, whatever, that need to like do something. At the same time, we might have some HCL that gets passed to Terraform, and Terraform creates some cloud infrastructure and maybe put some secret in somewhere. And then we got operators in the Kubernetes cluster that might also create cloud infrastructure or fetch some secrets and put those into config maps and secrets. And then these apps are supposed to like get values from these config maps and secrets that are being put through this. And I think just explaining like how this meets at the end is maybe highlighting enough. And I certify this as a standard stack. You might give or take a few Git repositories, a few tools, whatever, but like this is for the most part what I have seen in the industry, and probably this looks familiar, hopefully. So yeah. So immediately we could look at, okay, how do things go wrong? We're talking about config changes here going wrong because I can't remember the statistic now, but 80% of the time when things fail, it's because of change, which is amazing, right? So change is what we should aim to try and fix. So this developer or YAML developer changes something in the YAML, and it goes all the way through these tools, might even go through the Kubernetes API server without an error, but something goes wrong when Kubernetes is trying to run the pod or run a container or well, mount a config map or whatever could be going wrong. But we have to wait all the way down right to the bottom to see that there's an error, and that error might not propagate up. So we might actually have to go, to the command line or to a dashboard or to somewhere else to know that something is wrong. And that's a pretty big lead time and a lot of hidden layers, in my opinion. Because even when we get the error, we're like, is there an error in my config? Is there an error in the Helm chart? Is there an error in the customize? Where is the actual error? So, I mean, there's lots of problems. There's lots of good things with this too. But some of the main, high-level ones would be that the tool boundaries are weak. So
please name one good thing. Because
infrastructure.
You're not compelling me to use Kubernetes right now.
Yeah, that's fine. It's fine if you want to be that guy in the audience. I'm gonna yeah. There's a stack of beers around the corner. So after the when I can drink a beer as well, we can talk about whatever you want to talk about, and I'll just kind of answer with it depends, and we can call it a day. But I would say good things. Everything is as code, hopefully, and there's an automated process, and there's Kubernetes, which makes it great too. You see, we're going to have fun. But yeah, the tool boundaries are weak. So you pass stuff between these tools, and nothing really says this is wrong. It's just going to take it and be like, all right, I got it. Let's do this, and then finally at the end it's wrong. Templating pushes all the problems downstream, kind of similar. The cognitive load on this developer is really high because he's got to think HCL, Terraform, secrets management, cloud, then some YAML and Kubernetes, and there's nothing really helping him that much. It's usually a lot of just writing tons and tons of YAML, and the errors are not propagated. But I think the real problem is that we look at this and we're like, how do I make this better? Let's add one more tool to it that will help solve this problem. And I think this is really interesting because this was a mindset change for me in the last 6 months, maybe, because I would have been we can throw another operator in there. We can throw, OPA in there and, check stuff. And then we need to manage that and manage the configs. And the problem just keeps on going. So we had a couple of hypotheses. Hypothesis number one, if we can do everything in one context with type safety, compile time checks, we can reduce the number of tools that we use, we can reduce the cognitive load, and hopefully find some errors earlier, so shift left the stuff that we're doing. Hypothesis number two was if we can codify our process using a real programming language, then maybe we can start to automate things that, well, this is an interesting discussion I've been having a lot now, because technically you can automate everything with YAML and HCL, but who actually does it? And this is the really interesting part. It's I could picture it in my mind, but then you never end up doing it. And when you're in a programming language, it's so much easier to just start writing a test and start, building a kind of process that does something. So that was our hypothesis, that if we use a programming language, we can actually start building new levels of automation. And hypothesis three, well, I don't think this needed proving. We kind of knew that there was going to be more work in the beginning. And this was also part of my my distaste for doing things with programming languages in the beginning, was that people were telling me, yeah, you can get rid of HCL and do it in Python. And all I saw was okay, so now I have to start engineering a code base, writing tests and doing lots of things without the clear benefits. So. Anyway, I don't have much time. So I can talk about the stuff afterwards, but we did our little research, and probably now if you look on the 2022 CNCF landscape or 2023 CNCF landscape, you'll see some familiar faces here. But yeah, we looked at the likes of CDKTF and Pulumi, the sort of programming languages for building infrastructure and interacting with APIs and things. And Pulumi actually is quite like close to what we wanted, but the thing that we really lacked was that it still lacked type safety all the way down. It was like type safe on the surface, but then you dig a bit deeper and you lose a bit of type safety. And the other thing that we found with them that we didn't like so much, because we ended up using Go, because I can tell about why we use Go, was that it's very procedural. So you really you create your stack or whatever, and then you add things to the stack procedurally. So if you want to know what's actually in your stack, what's in your infrastructure, you have to dry run the code in your head. You can't just look somewhere and see declaratively that this is what I'm going to create. And I think that's a miss, because when working with Go, we have structs, and in a struct you can define what the fields are. So then you could declaratively do things. Crossplane and Cluster API, which is the friendly little turtles in the bottom left, they are Kubernetes operators. So you throw Kubernetes objects at a Kubernetes cluster and they go and do stuff for you, like create cloud resources, create other clusters and things. We wanted a single process, so a single workflow. And we worked mostly with Cluster API. So we were writing a Go program that would send objects to the Kubernetes cluster and then wait for the state to become ready in those objects. And that's a really annoying thing to do. So we decided we don't want to do it anymore. So that kind of wrote off any operators and things from our process, because we want to do something and then have it tell us when it's done, not do something and okay, wait and poll and check 5 different things, where did the error happen? We really lost a lot there. We also looked at Qlang. If you're not familiar with Qlang, configure, unify, execute is what Q stands for. So it looks a little bit like Go, and it's written in Go. And it's a configuration language where you can unify things, and I think that's really cool, because you can define semi-complete structs, and then you can unify those with the actual data a user is providing, for example, and validate it. So it has a lot of nice features beyond, typical YAML and JSON. But it's still quite a young project in a way, and we didn't want to, base our whole work around something that isn't quite certain yet. And still, we'd be interfacing from Go or a programming language with a config language, and that just felt unnecessary. So. Yeah, so the thing that was similar to Pulumi in a way is that it's declarative. So you create your stack, and then you add things to the stack. You don't really define, hey, this is my stack in one place, and then fill in those values. So it's very procedural. But I also tried CDK-TF with Go, and it just wasn't nice. It just wasn't nice. The auto-completion just didn't work. There's barely any documentation. I really didn't have a very nice time doing it. I think if you're in the TypeScript world, because all of these CDK and CDK-TF are all based on this JSII Node.js stuff, if you're in TypeScript world, maybe it's fine. So I think it's a bit like who you are and what you're doing might depend on your experience. But for Go, yeah.
But did you experiment with the native CDK from AWS? Because so it's abstraction over abstraction with CDK.
Yeah, so we didn't want to lock ourselves into AWS, but so I know that there are now Go bindings for AWS CDK, but it's still procedural, which we didn't like. Yeah, exactly. Yeah. I have some code examples. I don't have code examples of the others, but I have code examples of what we've done. Snippets, I should say. Our samples are snippets. So I can show you. Because where we landed was, we had quite some knowledge about Terraform in the project already. I've written some tooling around Terraform in Go as well, so I already knew the HCL library, I already knew the CTY or CT library, which is the type system behind Terraform. I'd already done some shelling with Terraform, calling Terraform CLI and stuff, so it I just needed to put those things together and get something else out. So we went with that, we went with Go, and we went with using the Kubernetes structs that you get, because Kubernetes is written in Go, so the structs for all the resources and things are available. And we had a couple of goals, feedback from the research phase. So we wanted the developer experience of Go, so everything should like autocomplete nicely, everything should be type safe, we should be able to write unit tests for everything. We wanted to avoid the asynchronous processes, so this would be like sending stuff to a server and then waiting for something to happen. We wanted to avoid that. We stopped fearing the shelling. By shelling, I mean like invoking a CLI or something from Go. At first, we tried using the Kubernetes Go client libraries and communicating with the REST API natively. I can talk to people about that if they're interested. We ran into like problems, and then we found tools like Siili and other like fairly like cool modern CNCF landscape tools that also shell out to kubectl or have a wrapper around kubectl. So we kind of thought that why are we fighting uphill when other well-established tools are not? So we stopped doing that. And yeah, we wanted a single workflow over a single tool. So we didn't really care that much, what we actually used to get where we wanted to be, but we just wanted that single, like, nice process to get there. That was the goal. So we actually ended up writing some stuff finally. So we wrote a code generator for Terraform. So that's this tfgen box here. You basically pass in the Terraform providers you want. Like I want the AWS provider. Here's the source and here's the version. So command line arguments, and we generate a bunch of Go structs for the provider, for the resources, for the data sources. We have the arguments, which are basically the inputs. We have the attributes, so you can depend on things within Terraform in our across these structs. And then we have the states as well. So once we've ran Terraform and their states, so things like what Terraform actually went and created, like the cloud resource IDs and whatever else, we decode those back into the Go struct. So we have the state in Go ready for the next thing that we're going to do with it. So you run the generator, it generates some structs, and then you write some user code which uses those, and then we have an export method which dumps out HCL, and that's basically the library. It's actually not that complicated. It was more about getting the developer experience to be good. That took some time. And then there's a library for shelling out to Terraform CLI, which we use. So that's how we built something to interact with cloud infrastructure. Here's an example for an AWS EKS cluster. So this is these sorry if you don't know Go. Sorry if you don't know C either, and I have to explain what a struct is. But a struct is like a class, except, well, it does have methods in Go, not in C. Anyway, so we have a struct, and then these types like AWS.EKS cluster, that is a generated struct from the AWS Terraform provider, because there is a type AWS_EKS_cluster if you look in there. So we define our stack. Well, this is more like a module in a Go struct. So anyone can look at the code and be like, okay, what does this thing actually do? Well, this is what we populate in a function. So we create like a new EKS cluster method or whatever, and its goal is to fill this in based on the parameters that we put in the function. And we have simple validation stuff built in as well. And yeah, if you run the export method, then you get something that looks like HCL out the other end. And this is what we then run Terraform over. On the Kubernetes side, we wrote a bunch of utilities. Two of the main ones, we have a Kaigo command line tool, which is Kubernetes YAML to go. So you can basically do a Helm template, customize whatever, get some YAML out, throw that into the CLI, and get Go code out at the end. This is a starting point. It's not like, here's the Go code, it's done. It's a starting point, so you could get going from somewhere and then refactor the Go code later. But then as well, we have an export method, so you can throw in some Go code and get some YAML out. And yeah, structs already exist. And as most custom resource definitions and operators and things are written in Go, then those structs already exist too. So if you need to create custom resource definitions, then you can just import those in Go, which is wonderful. And here's an example Go struct for Carpenter in this case, which is a autoscaler for EKS, a really nice one. So yeah, it's the same thing again. The struct is a bit longer. When you really start to own Kubernetes manifests and don't rely on Helm so much, you really start to see how much stuff you start putting in your Kubernetes clusters, and it's a good wake-up call. But yeah, again, we have a declarative kind of approach using a programming language because it's very clear, like what we're going to be generating. So we can build a really simple example CLI, and this is not too dissimilar from what we're using now, just with a few more steps in it. So we have a Go main program which calls, oh yeah, sorry, the purple boxes are the Terraform stuff, and the pink boxes are the Kubernetes stuff, and then this happy green triangle is the Terraform state. Now that you know what I'm talking about, hopefully. We have a Go main program which creates like a VPC stack based on our Terraform struct, runs Terraform, plan, apply, whatever, imports the state back into the struct. So now we can have the VPC ID, we can have the subnets, we can have all of the things that we need to create an EKS cluster in Go. So we pass those values to the EKS stack, create the EKS cluster, get the state back, pass that now to something like Carpenter. And this is where things get fun because Carpenter is both cloud resources. We need IAM roles, mostly just IAM roles. And we need also some Kubernetes manifests to send to the Kubernetes API. But I mean, the two are very coupled. You need to create the IAM roles and get in AWS world, the ARNs, the IDs for those, and send those or provide those to the Kubernetes manifests to say, hey, this is your role, run as this. Well, if you remember my earlier diagram, this is where things start to get a bit hairy. But in our world, it's wonderful because we create the Terraform stack, apply it, we have the state, and then we pass like type-safe values into our Kubernetes app, which is also a Go struct. And it worked first time. Like, I'm not kidding. I just wrote it and it worked. The only thing that didn't work and wasn't great was the AWS permissions. So if anybody knows how to do AWS stuff in Go, or just in general.
Nobody.
Yeah. So principle of least privilege is great in practice, but boy, like. Anyway, yeah. So I mean, that's basically it. And then more stuff. But it's cool. I mean, if anything failed at any point here, we would just handle it as a Go error, which means we propagate it up to the command line interface. And what you're running in the terminal, you're going to see like, sorry, could not create the Carpenter app because something failed when I was doing this, and that was because this happened, and that was because this happened, and now you have like a drill down to exactly where the thing went wrong, and that's wonderful. So this might be a little bit to take in. It's mostly like, I just wanted to give an example of how we create a Carpenter stack, which is the top bit. Notice there's 3 dots in the middle. That's like a separator, not valid Go code. But the top bit is creating the Carpenter stack. So this is the Terraform stuff. And you can see these like state must. We've already checked that the thing has state, so we can safely do state must, because in Go world, something suffixed with must would usually panic if it doesn't work. But this is fine. So we can get these values out, we can pass it into the stack, and then we can do the same later on to pass into the Kubernetes app. And if we misconfigure something, guess what? This won't even compile. We'll get a little squiggly line in our IDE telling us that, like, hey, you can't pass an object into a string. You can't do this here, it just doesn't work. And we get completion whilst we write this as well. So if I don't remember exactly what I called the field, I just hit Control Space, and it's like, oh yeah, the instance profile something, and then it comes up. So. Couple of like notable mentions, so things that we found really helped us, because we started this, and then we started to write utilities to wrap up the stuff that we felt we were doing repetitively. Things like role bindings and service accounts. So we never misconfigured those anymore because we created the objects in Go as structs and passed those structs around. You can't refer to the wrong service account or to the wrong role if you're using a programming language in types, because, well, either the programming language is broken, which it's not. Same with volume mounts, labels and annotations, so we can pass those across, cloud infrastructure and Kubernetes apps now without problems. And one of the things that I really enjoyed was writing a simple struct for AWS auth. So anybody who's worked with EKS and the AWS auth config map, which handles the permissions for who can do what with the Kubernetes API. Configuring this config map is really fun in YAML, like really fun. So I really enjoyed like doing it with type safety. And again, it worked the first time. It was just like, okay, like I can give this to anyone now and they can't do it wrong. Like, well, they can, but like 80–90% of the common errors won't be there. How are we doing for time, by the way? Because how was everyone doing for brain capacity? Yeah.
No worries.
Okay.
Half an hour gone.
Okay. Yeah. Oh, there is a TV screen there. I thought everyone's been looking out the window, like, like, what amazing, this TV screen. Okay. But yeah, so I mean, this is kind of the point where we're up to. We've done a few more things now, which I'm going to talk about, and then there's stuff that we have just conceived in our minds and discussed together, but not really started to implement. And anybody who's worked in managing tooling, stacks, platforms, whatever you want to call it, for teams, will know that maintaining versions and keeping things up to date, and remember 80% of the time things go wrong is because of a change, keeping stuff up to date is a real pain. So we were like, okay, now that we have everything in Go code, it's basically data that we can refer to, can we start to build some processes that help with the automated updates and stuff? So we did. This is still a work in progress, but basically we can like code something that would, let's say we start off with a Helm chart as the start. What if we now go and get the latest version of the Helm chart and get the versions of the Docker images or containers, whatever versions they are, and all the other changes that have occurred, and do some kind of smart diff. And by smart diff, we're checking for changes to arguments to containers. We're checking for changes to config maps, changes to custom resource definitions, stuff that if we go ahead and just deploy, it's probably going to break. What we might not care about are things like labels or annotations, or just, like environment variables that we didn't like use in the first place. So it's trying to sniff out the stuff that we need to now change and ignore the stuff that like this doesn't affect us, which is going to be a continuous process, but whatever. So yeah, relevant changes. If there's no relevant changes that we need to make, then create a test environment. So create a new Kubernetes cluster or something, deploy the dependencies that we need, deploy this new version of the app, run our tests over it. Does it work? If it does, then maybe we can raise a PR for the team to actually say like, yeah, we tested this, it works. Why don't you, approve this? And if there are relevant changes that need making, then sure, we have some manual work to do. But I don't think it's possible to ignore manual work when we maintain tools, especially ones that we don't control. But the goal here is to like create the test first. So how do we get this source manifest? Maybe we can write a test for that. So we already start to automate stuff before we even go to production, or even like start to test stuff. And something else that we did, which was fun, was And I don't know how many times I've had to do this manually. So this was wonderful. Whenever you have like a database that some service depends on and somebody's like, hey, can you test an upgrade? And you're like, yeah, okay, I'll snapshot it. I'll create a new one. Maybe you have some Terraform module or whatever to do it. But still, somebody sat there driving this process usually. Create the new database from the snapshot, deploy the new app, maybe in a new cluster or maybe in a new namespace or however you're going to do this and check that it works. I think this took maybe like, 2 hours to code once we had the reusable blocks. And now we have a test method. I mean, we do this per app, so it's very specific, but that's fine. We have a reusable block for how to snapshot an AWS RDS database and create a new one from it. So we can reuse that now. We can do the same for S3 and for Elasticache and whatever other funky databases you want to be using. So that's really cool. So now we can like automatically provision cloud infra and deploy the stuff in like a single context again. So if it doesn't work, we get the error quite quickly. And we've been toying with the idea of maybe we don't just stop there. Like maybe we could start to do things now like blue-green upgrades or whatever with third-party tools that we maintain in our stack. But yeah, this is still like, this works. But what we're going to do with it is still, fermenting. And then some blue sky thinking. So this is stuff that like we have just discussed, but there's nothing really there yet. Now that we're creating all this stuff, maybe we can start writing to some database exactly what we're doing, what we're creating, have some kind of visual of our infrastructure and of our services, and start to do some cost management. I mean, we have the data in our Go code. We already have the process in Go of how to do it. All it would be is like one extra function call or something in that process. It wouldn't even like change anything for the user, for like developer experience. So, things like unit tests for policies and automated analyses. So yeah, like maybe we can do a lot of the things that we would do in CI and maybe on the cluster level as Go tests and integrate tools that we might use to, could be some security testing tools, could be some policy checking tools, could be, whatever. Maybe we could write some little utilities in Go and include those as test cases, so like unit tests. So as a developer, when you're writing a new module, you just run Go test, and you're like, hey, like here's your Terraform stuff that's not secure. Your S3 bucket is open to the world. Don't let it be. I've made the mistake many times. Yeah, please.
Have you thought about using, for example, console for the policy testing?
I mean, Sentinel.
Yeah, excuse me.
Yeah. No.
It's got some quite okay structs.
Yeah. I might almost not use a tool for it. Maybe. I might not bring in OPA or Sentinel. I might do something in Go, very minimalistic, specifically for our use cases, or then throw like automated tools at it that we configure, rather than starting to write. Or if you could write, probably what would swing it, because OPA is written in Open Policy Agent, is written in Go. Probably you can write the rules in Go as well, and that might be a big win. Like if we could write the policies in Go as well, because the horrible thing would be to have all this nice stuff in Go, and then write YAML or JSON or Rego configs, which is what OPA uses, and then reach the gap. But no, Sentinel, no, I haven't thought about it. If you have some nice examples, I'd be very happy to see them. And another thing, like all these services we run are going to need to have their own observability setup, metrics collection, Prometheus rules, whatever else we want to add. For the most part, they're going to be very similar. There might be some subtle differences. So what if we can write utilities to create those, and then kind of like out of the box for all of our apps, we would have some base level of metrics being collected, open metrics or whatever, and some rules set. And it's type safe. You can't write a Prometheus rule in a Go struct. I mean, you can still get it wrong, but that 80-90% of where the errors could go aren't going to be there, and you're going to have auto-completion. So it's immediately even if we don't write a utility for it, you're immediately making life easier for you. Kind of things you could build with this. Well, we've been mainly building like platform tools. So these would be tools to help us manage the platform that we are running. You could write developer tools. So you could have like CLIs for the developers to spin up things that they might need. I don't have any concrete examples, just, you know, maybe you have some concrete examples. One of the concrete examples we have been talking about is building our own Kubernetes operator, because why run other people's Kubernetes operators when you can run your own? I am joking a little bit, but I mean, there is some stuff like onboarding. Like, so a new person wants to get access to your services, how do you grant them access? Maybe you have a UI, or maybe you have some way that they can request access. What I have really struggled with is keeping that up to date. So you add a new service, how do all your existing users get access to that service? What about when somebody leaves and you need to offboard them? And I find the Kubernetes control plane to be very good for these kinds of things, because there's lifecycle management, there's reconciliation, there are finalizers for offboarding things. And now that we have wonderful Go libraries for working with, you know, Terraform and Cloud Infra, and well, I mean, you don't even need those. Most of the time, it's just calling a REST API that, you know, create this user in your database. We could do some nice stuff there. So going through the hypotheses, number one, we definitely have less tools to get to where we need to be. I mean, we're still using Terraform, we're still using other things, but there's less. And it's done from one like context, which is really nice. So I would say the cognitive load has been lowered because we're not context switching all the time. And definitely less errors, and the error handling is actually really nice. So we don't use Argo, we don't use Flux, we don't do wonderful GitOps, all the amazing things that I've been talking about for the last whatever years. We just have a CLI tool we've built that creates clusters and bootstraps them, and it's like, it's wonderful. It probably will evolve into something a little bit more complex, but like, I really like how simple we've made it for now. And we've been having some rules that don't, you know, don't invent stuff until it hurts. So don't just do stuff because you can. It's like, wait for the pain to come. When you know what the pain is, you actually know what you might be trying to solve. So, about codifying some more automation, well, the initial feeling is very positive. And we found that once we started to codify some things like the RDS snapshot and stuff, you know, that's reusable now. Once we do 5 of those, we pretty much have coverage of most things in AWS. So it's kind of scary at first, but then like, oh, there's not actually that much variety in things. So yeah, the real question is how far can we take this? But I guess it's always going to be, you know, a balance. Like, you only can put in so many hours and get so much return, and then you get to a certain point and you're just doing stuff, and maybe the return isn't so high. So I think it'll be like maturing into new ways of working, and that's how we see it. We're not like, we don't need crazy things. Let's just solve actual pain that we have today and see where we can take this. But we know now that we don't have like what I said earlier about like everything can be automated with YAML and HCL, but how many people actually do it? And I think it's because it gets so complicated. You have so much glue, you have so many bash scripts, you have so many like things that just piece together in a not a nice way that people just kind of like, okay, that's enough. But now we already feel like, you know, like we're hungry to do more. We know we can do more, but we don't want to because we don't want to just, you know, do stuff. So that's a really nice feeling. And this was more work in the beginning. Benefits were quite clear early on though. But I guess the big like warning there is that this probably isn't for everyone. If you're like a small team, and especially non-Kubernetes and working with serverless, and you really don't maintain many services yourself, then you know, maybe you don't need this. But if you're part of a bigger company and doing some platform for teams and using Kubernetes and managing tools in Kubernetes, then I would encourage looking at this at least. Is this only a config management problem? So what I mean is, are we just like, is it just a problem with YAML and HCL or any other config language? And getting that good? I think it's more. I think it's like the process. rather than bringing in tools that have a process for doing things and then us kind of like shoehorning that to work for us, we're building the minimum process to do exactly what we need, and that's kind of nice. So I think it's more than just solving config management. I think it's just about building nice processes that can be reused and tested and yeah. I guess these slides are going to be distributed, maybe. It's because I have some links for fun stuff. So people who want to read more about this, there's some interesting links where you can go. I can always share these just in LinkedIn or Slack or the meetup group, because these are quite fun. Yeah, thanks a lot for listening. Sorry, that was much to take in. And I was asked to give a shout out to Volvo Cars, because that's where we've been doing this, and they're doing really cool stuff. And also to my colleague there, Julian Visconti, who's the guy who pushed me and challenged me not to just keep doing YAML. But he was the one who was like, we need to do this as Go, we need to make it better. And then I was happy to join along, and now I think we've done something quite cool. So if you're interested, you can talk to me. And hopefully very, very, very soon, very soon, because I'm going on paternity leave in a week and a half. So before that, I hope we have these 2 libraries open sourced. Because, yeah. The end.
Because there's no immediate questions, so let's make a short poll. So if you are using Kubernetes, raise your right hand. If you are using Terraform, keep your hands up. Keep your hands up. If you are using Terraform, raise your left hand. And if you love YAML, put your hands down. Okay, everybody who is having hands up needs to have a question for this guy. As you heard, he's making this open source, so you might be interested in stuff, right?
I guess in your initial slides, it said that you were opinionated, and I can clearly see the opinionated side of your personality here. My question will be then, did you reach out to any of the open source communities of the tools that you showed there before and have a discussion of why they followed the philosophical paths that they followed and how it could interact with yours? Or instead of building the tool from zero, supporting those open source projects?
It's a really great question, actually, because yeah, it's very easy to think that yeah, I'm going to do this myself and do it different, and then these communities often need a lot of love and support, so it's kind of counterproductive. But I mean, I think really how we felt about it was that there wasn't something simple that did what we needed it to do, and we didn't want to inherit these projects that are quite big and quite mammoth. And that's why the things that we're open sourcing as well are very minimal. It's literally you can create ghost structs and export to HCL. We're not providing any clients. We're not providing any extra stuff. If you want to use this, you have to code that yourself, because it's going to be opinionated. And as soon as we try and do something general for opinionated people, it's going to become a monster. So I think that's yeah. I guess in part as well, we didn't realize quite how this was going to sort of go. I wouldn't say it snowballed. I was about to say snowballed, but it didn't snowball because the libraries are not that big.